Okay, hello, and welcome to the BA215 webinar presented by the Math Center, the Learning Center at Grantham University. My name is Denise Williams, and I will be your narrator today. This is webinar number 6 in a series of webinars that have been presented on helping BA215 business statistics students succeed in their statistics class by making use of the technology provided in Microsoft Excel. As a reminder, I'm using Microsoft 2013, Microsoft Office 2013, and I will be using something called the Data Analysis Toolpack. If you are unfamiliar with these things, please go back to the first webinar in the series underneath the corresponding folder on the Math Center website and see how to download the package that we'll be using. Okay, so we're going to carry on today. Today we're talking about comparing data sets and in particular interpreting confidence intervals. Last webinar, we talked about how to uh, develop confidence intervals using Microsoft Excel. We spoke about uh, 1 minus alpha times 100% confidence intervals when the population standard deviation was not known and when it was known. Oh, there's a typo on this. When it was known and when it was not known. Now today we're going to be talking about if we have two data sets, two or more data sets, and we're asked to compare the data sets. For example, we're asked to find, if we look at question D, on this page, they're asking whether or not it appears that the means are different for the two data sets. Now, how are we going to go about doing this? We're going to use the same information that we talked about last webinar with finding the confidence intervals, but today's lesson is not going to focus so much on how to find them in Excel. We're going to review that, of course, but today's lesson is going to speak a little bit more about how to interpret the information that we come up with. So let's first start with our review. Again, there's a typo on this slide. It's a 1 minus alpha 100% confidence interval if sigma is known. When sigma is known, and that's evident by the requirements that's listed on the left side of the slide. Sigma is known, the population is normal, the samples is taken from a simple random sample, and if the population isn't normal, then at least the sample size is large, which means that it's greater than 30. Now, this particular formula using the z table is not often used in practice. What is often used in practice is this formula on the next slide. So now this one has no typos on the PPT, and what it says is that if we don't know the population standard deviation and we're trying to make an estimate about the mean, we have to make sure that the assumptions are met. The first one is that the population comes from a normal population, a normally distributed population, or that the sample size is significantly large, meaning that it has to be, in this case, we're going to say that it's greater than or equal to 30. Also, that the sample is taken randomly, and that there are no outliers evident in the sample. Outlier means extreme value point. Now, if this is the case, we have a formula for the 1 minus alpha times 100% confidence interval where sigma is unknown and we're trying to find an interval about the mean, the population mean. Now here, x bar in the formula is the sample mean. T alpha over 2 is taken from a T distribution table with n minus 1 degrees of freedom. None of this is important to you right now because you use Microsoft Excel to do the problem for you. It is, of course, helpful to know where the information is coming from, but it's not necessary since we have Excel for us. Now, what is very, very important and that I would like for you to remember is that when we have a confidence interval formula as stated on the screen, it's broken up into two parts. The part that is before the plus or minus sign, the part that's to the left of the plus or minus sign, this is referred to as a point estimate of the sample mean. This is referred to as a point estimate of the sample mean. Now, what's on the right, the point estimate or the sample mean, I'm sorry, the point estimate or the sample mean. And the part that's on the right is referred to as the margin of error. So the part on the right that starts with T alpha over 2, and then you multiply that times S over the square root of N, this is referred to as a margin of error. Now, this is important because when we do this in Excel, Excel gives us two values. It returns a point estimate and it returns a margin of error. And we have to do a little bit of handwork for us to come up with the actual confidence interval. Now, last time we talked about the formulas that we would use in Excel if we were to come up with the confidence intervals about the mean. The first one on the PPT is when the sigma is known. Now, when the sigma is known, we would use the formula is listed there. But when the sigma is unknown, which is most commonly the case, which is what normally happens, then we would use the formula there with confidence.t. But what we're going to focus on today is the last formula when we have raw data. When we have raw data, instead of putting in the formulas confidence.norm or confidence.t, we can actually go directly to the data analysis toolbox, the data analysis uh, add-in that we talked about in the first webinar, and we can go ahead and run the descriptive statistics portion of this, and this will give us our margin, I'm sorry, it will give us our point estimate and our margin of error. So we're focusing on the raw data analysis descriptive statistics for today's webinar. Now, before we actually do a problem, I want to make sure that we understand what it means when we run the confidence interval. So say we have a whole bunch of information, or we're trying to find out something about a population, but the population data is not available to us, and we only have sample data. Now, based on the sample data, we can guess, or we can come up with educated guess of where our population average would be. So we wouldn't say our population average is specifically one number. We would say that our population average is between a range of numbers. So this range of numbers is our confidence interval. When we say we have a 1 minus alpha times 100% confidence interval, this is also called the level of confidence. Now, if we have a 95% level of confidence, for example, this means that if we were to do 100 confidence intervals, we were to do the same 100 times, 95 of them, or 95% of them, would actually contain the mean. The higher our confidence level, because we can pick 90%, 95%, 99%, the higher the confidence level, the more chance that the confidence interval that we have come up with contains the mean. So let's look at another example. For example, if we have constructed a confidence interval with a lower bound of 12 and an upper bound of 18, now what that means is that we have an interval with a 12, comma 18. 12 is the lower bound and 18 is the upper bound. What it would mean if we're doing a 90% confidence interval is that we're 90% confident that the population mean is between 12 and 18, that this interval is one of the intervals that contain the mean. The reason why this is important, the interpretation part, is because in your week 7 assignment for BA215, you're asked to actually interpret the interval, not only to compare the data sets, but also to interpret them. So this part is very important. Now let's go on. Here's an example of where we would be asked to compare the data sets and use confidence intervals to do that. Now, this problem is taken from another textbook, not yours, and it's talking about the number of hours worked per week for a random sample of 15 adults in the USA and in Canada. Now, the quest here, the researcher's quest, is to compare the number of hours worked for Americans and for Canadians. Americans work very hard, and Canadians as well. So, is there any evidence based on this sample to assume or to conclude that the average number of hours worked for Americans is greater than the average amount of hours worked for Canadians, or vice versa? Is there any way for us to compare that? And yes, there is. We can compare it using a confidence interval. Now, here, this problem lets us break it down step by step. First, we're going to come up with a point estimate, which, remember, is the average for each of the countries. And then we're going to construct a 99% confidence interval for the US, and then a 99% confidence interval for Canada. And then we will compare the two. And then we'll compare the two. Now, what I'm going to do is use Microsoft Excel. So let's go ahead and open up our Excel. And I've already entered our data into a Excel spreadsheet. In the first column, I have USA, and in the second column, I have all the data for Canada. Well, someone in the USA works 70 hours per week compared to the first entry, and Canada is 49. Now, based on my own previous experience and based on the data, at least the first numbers, it seems like Americans might work a little bit more than Canadians, at least based on the first two data points. But I don't know. Here, the Canadian works more than the American, its counterpart. So, what is my final conclusion? What will I do? Now, because I'm asked to come up with the point estimate for the A part, and I'm asked for the confidence interval for the B and C part, I'm just going to go ahead and do everything at one shot. The first thing is to go to my data tab. So remember, this is Microsoft Excel 2013, where I have installed the data analysis toolpack. Now I go to the data tab at the very top of the screen, and then I go to the very right where I see data analysis, and I click on this. This will open another dialog box, another box. And in this box, I have many choices. I'm going to click on descriptive statistics and press OK. Now, this descriptive statistics box is going to give me, this descriptive statistics tool is going to give me all of my answers for A, B, and C right away with only one click of a button. So the first thing that I have to do, though, is make sure that I have inputted all my data. And I'm just going to highlight rows A and B for my input range, grouped by columns, because the data is separated by columns. And then in the first row, because I have USA here, Canada here, I'm going to click labels in my first row. My output range, I don't want my output to go into another worksheet or another workbook. I would like it to stay on the same worksheet, working for a living. So I'm going to make sure I click on this output range, and I'm going to go click on an empty cell here, D1, and this tells me that my data will show up here. What do I want? I want them to give me the summary statistics and I want a confidence level for the mean. Now, this, if I looked at B and C, they're asking me for a 99% confidence interval. So make sure that you change the confidence level from the default of 95. Now I think I have everything that I need. I just press OK. And what has it given me? It's given me all of the information that I'm asked for. Here is the point estimate of the mean, 42.33. This is referred to as the point estimate of the mean. So 42.33 is a point estimate for the USA, and 40.8 is a point estimate for Canada. This is the A part of the problem. So let's go back to our presentation. See, the problem asks in the A part, obtain a point estimate for the population mean number of hours worked each week for each country. And based on what we have seen on our Excel spreadsheet, the point estimates for the USA are 42.3 continuous and then 40.8 for Canada. So it seems on average, Americans work a little bit more than Canadians, about 1.5 hours a week more than Canadians. But is this difference significant? Is this difference really significant? The way for us to compare that is to compare the two is by looking at the confidence intervals. This is one way to compare the two. There's a difference, but it might not be that significant. And so what we're going to do is answer the B and C parts of the question. Oops. Answer the B and C parts of the question. The B and C parts ask us to construct a 99% confidence interval for the population mean for the number of hours worked each week for the United States and Canada. So let's go ahead and go back to our Excel spreadsheet and see about the answers for C and D. Now we have here our A part, remember? And what we want now is to find our confidence interval. Now underneath the table that was was produced by Data Analysis Toolpack, I have typed in the lower bound and upper bound. This I typed in on my own, lower bound and upper bound. I typed in on my own. And now what I'm going to do is I'm going to use the data that's here in this table to give me my lower bound and my upper bound. This is just math. Now I have this confidence level, 99%. This is also something that's very important. I'm going to highlight. These are the things that we're going to have to use. This and this. Okay. Now, for the lower bound, I'm going to take my point estimate and minus from it, subtract from it my margin of error. This confidence level that is generated by the data analysis toolpack, this number is my margin of error. Remember, this is the number that's on the right side of my formula. And so what I need to do is I'm going to put in my equal sign and take this and subtract this, which gives me 31.4. For my upper bound, I'm going to take my mean and add to it my margin of error, which is 53.24. I'll do the same thing for Canada. So I have my mean and I subtract my margin of error, type equals my mean added to my margin of error. So these numbers are my final numbers for my confidence interval. For the USA, an we have a confidence interval, a 99% confidence interval of 31.4 hours to 53.2 hours. For Canada, we have a lower bound of 31.05 hours and an upper bound of 50.55 hours worked per week. So let's go back to our keynote and see what this all means. What does it all mean? Now, for the USA, the interval is 31.43 to 53.24, and we just showed how we got that on the Excel spreadsheet. What this means is that we're 99% confident that the population mean is between these two numbers, between 31.4 and 53.24 hours. For Canada, we're 99% confident that the population mean for the entire country of Canada is between 31.05 and 50.55 hours. So let me restate what this means. Now we looked at a sample of only 15 people, but the population of Canada, the population of the US, actually, I don't know the population of Canada, but I know that the population of the USA is somewhere around 330 million people. And of those 330 million, not all of them work because some of them are kids. But for those that are employed, for those that do work, the average for those millions of people that are working, the average for all of them, we're 99% confident that it's between 31.4 and 53.24 hours. The same can be said for Canada. For all of the people that are employed in Canada, we're 99% confident based on the data that they work between 31.05 and 50.55 hours. Now, if we look closely at these intervals, they seem to look just about the same. Maybe the interval for Canada is slightly to the left of the interval for the USA, but they're pretty much overlapping. It doesn't look like there's a big difference between the two countries based solely on the confidence intervals that are provided here, based solely on the data that we've come up with. It doesn't seem like there's a big difference between those two numbers, these two intervals. And for that reason, for the D part of the problem, we can conclude that there doesn't appear to be a significant difference between the working hours between the USA and Canada. Looking only at the intervals that are provided there, they don't seem to be very different. Okay, now let's go on to another problem just to make sure that we've gotten this. And this one is again taking data from 30 individuals, but here instead of comparing countries, we're comparing genders, outputs by gender. So we have 15 males and 15 females that have taken um, a math test, and the scores for the males and the females are being compared. We want to know because this is actually a very interesting thing to study because people often say that women, for whatever reason, do not excel in mathematics to the same degree as their male counterparts. So, is this really true, or is it just an old wives' tale? So, what we can do based on the data here is compare the two groups and see whether or not there is a significant difference between the two groups. Now, again, we're going to follow the directions, follow the steps that are um, highlighted on the screen. The first thing is for us to get point estimates for the population mean. That means come up with averages based on the data that's there. But we're going to do it for males and for females separately. Then we're asked to construct a 95% confidence interval for the males and one for the females. And then we're asked to compare them. So let's go ahead and do that. The data, remember, it's here. This is our data. And I have already put it into a spreadsheet. Again, I've already typed in the lower bound and upper bound that we're going to need later. So this is not generated by Excel. I've typed this in. But what I do have, that's what I have also typed in, is this male and female, the data set. And just looking at it, it's a little bit difficult to compare. The numbers seem to be just about the same. At some points, the female scores are higher than their counterparts, but at some points, the male scores are higher than their female counterparts. So it's hard to come up with a good conclusion based solely on looking at the data. So what we're going to do is come up with our confidence interval. We're going to follow the steps that we have done previously. I go to my data tab at the top of Microsoft Excel spreadsheet, and then I go over to my data analysis tools. I open my descriptive statistics window, and first I click on the input range cell, and here I'm going to highlight my data. Again, it's columns, and the labels are in the first row because they're males and female. The output range, I want it to be here. So I click on this empty cell, and I click on this cell. I want to come up with my summary statistics because I want to find my mean, and that's the only way that I can get that, my point estimate. And my confidence level, the problem asked me for a 95% confidence level, so I change that there. I press OK, and my data comes up here. Now, what is the information that I need to focus on? First, the mean. That's very important. And then my confidence level. This is also very important. So these are the two important data points that have been generated by the analysis toolpack. Now, the first thing that I'm going to do, instead of going back over to the keynote, let's just finish it up here. The lower bound is equal to this minus my confidence level, my margin of error. And then my upper bound is equal to my point estimate plus my margin of error. I'm going to copy these formulas and paste them here. So I have 4 females. Females are the second columns, second data set of data. For the females, we have a lower bound of 421 and an upper bound of 486. For the males, we have a lower bound of 419 and an upper bound of 474. Now, it looks like the females are actually slightly higher, but our confidence intervals overlap. They're just about the same. So if I go back to my spreadsheet where I have already inputted my data, what do I have? Now for the point estimate portion, we're asked to come up with a point estimate. We have males have a point estimate of 446.5 447, and females have a point estimate of 453.5. So on average, the females are a little bit higher than the males. But their test scores are a little bit higher. But this difference might not be significant, and that's important in statistics. We've said that, we've talked about that in our previous example, that even though it looks like one number is bigger than the other number, that difference might just be an anomaly. It might not be statistically significant. So what we do is we construct our confidence intervals. And for males, the intervals are between 419 and 474. And for the females, it's between 421 and 486. Now, just going based on these two numbers, just based on these two intervals, I would say that they're just about the same. I would say that there's no real basis for saying that women score higher than men, and definitely not that men score higher than women. For one, the sample is really small, and for two, the data is overlapping each other. So for the D part, I would say that there appears to be no significant difference between math achievement for males and females based on the confidence interval. Based on the confidence interval. Okay, so what have we talked about today? Today's webinar was a little bit shorter, only about 30 minutes. But what we have talked about today was good. We mentioned again point estimates and how they relate to the confidence interval. We talked about how to interpret the confidence interval, and importantly for this section that's talking about data analysis in Excel, we talked about how to, with one click of a button, come up with the answers for the A part, the B part, the C part um, simultaneously. So the only difficulty then is for you to analyze what you come up with. And so your interpretation of something might be different from my interpretation of something. I look at the intervals and I say that there's no real difference. But you can look at it and say you think that there's a difference, and you just have to explain why. You just have to explain why. This is the beauty of statistics. Everything might be right as long as you can explain why. Now, if you have any questions, please don't hesitate to contact us at the Math Center. We're ready, willing, and able to answer any of your statistics related questions. Any other math related questions can also be answered by one of our competent instructors, competent tutors. If you have any questions about technology, again, I was using Microsoft Excel 2013. But if you are working with any other type of computer, a MacBook, Linux, or anything else or any other version of Office from the 2013 version, please don't hesitate to contact us at the Math Center as well. We can also help you to use technology for in whatever case, in whatever scenario that you might have to use it. That's it for this webinar. I hope you have a nice day. Thank you for coming.